Hi, good morning. And today I am going to discuss about motor protection principles like induction motor. And we we are having a our maximum our industries are having motors. Maximum load of the industry maximum load is industrial load. Our load is industrial load, and in that maximum load is in industries maximum load is motors, and in that maximum motor load is due to induction motors. Okay, that's why we need to protect induction motors. We need to protect the motors. Okay, and induction motors having different ratings and everything is there. And if you want to concentrate on this, like where first which motor came, and the first US patent for a motor was issued to Thomas Davenport in 1837. And next, in 1888, Nicholas Tesla patented the AC polyphase motor. Okay, these are the first motors. Okay, first motor is 1837 DC motor, and after that 1888 AC motor. Okay, and electricity consumption by motors in manufacturing sectors 70% in oil. 70% of the electricity is consumed in oil in the oil manufacturing companies. 70% of the consumption is due to motors only. And um, in gas mining industries 90% of the consumption due to the motors only. Okay, three phase squirrel cage induction motors account for over 90% of installed motor capacity. And motor, if all motors are within that maximum motors, 90% of the motors are three phase squirrel cage motors. Okay, that is motor history and facts. And next, where we are using the motors, we are using a motors in fans, blowers, pumps, compressors, grinders, chippers, conveyors, shredders, crushers, mixers, cranes, extruders, refiners, chillers. These are the various applications of the motors. Okay, then what are the failures? Maximum we are having a some failures are there that we are classifying that failures into different failures, like according to IEEE study, this failures percentage is due to overload 4.2%. 4.2% failure is due to overload, and due to normal due to normal deterioration 26.4%. Okay, and like that we are that they are classifying that loads into that failures into a different category. And according to EPRI study, that stator ground insulation 23%, turn insulation 4%, bracing, core, gauge, these are the different first. And high vibration. And first these faults are electrical related failures, and these are the mechanical related failures. So these are the environmental related failures. What are mechanical means? High vibration, poor lubrication, and sleeve bearings, anti-friction bearings, thrust bearings, rotor shaft, rotor core, and these are the mechanical. What are the environmental means? High ambient temperature, abnormal moisture, abnormal voltage, abnormal frequency, and abrasive chemicals, oil leakage, bearing seals, frame, wedges. These are the environmental. And if you are taking average of that, means electrical related failures are 33% and mechanical related failures are 31%, and environmental and maintenance and other um, environmental maintenance and other reasons are 36%. Okay, these are the different failures. And next, if you want to see the, you can see the motor here. This is stator and this is the frame, and these are the bearings, and this is shaft, and this is rotor. Okay, in that most of the motor failures are due to the temperature related to overheating. Okay, thermal stress potentially can be cause the failure of all major motor parts: stator, rotor, bearings, shaft, and frame. Okay, maximum our motor failures are due to the overheating. Okay, we need to protect that. And if you are taking a this stator windings insulation, that stator winding insulation we are classifying as a class A, class B, class F, class H. Okay, that the winding temperature is increases, means then it will damage, that lifetime will decrease. You can see here class A is around some 100 degrees to 150, 150. After that it will lifetime will damage. And class B is like this, class F is like this, class H is like this. If class level is increasing, means that cost also will increase. According to our requirement level, we need to choose the class. Okay, and next, what are the electrical faults? And thermal overload, process caused excessive load. If that load on your motor increases, that is thermal. And high ambient conditions, hot, that the temperature is too increasing too much, and power supply issues, due to that also temperature will increase, that is also one of the thermal. And phase faults and other ground fault, and another abnormal operating conditions like over voltage, under voltage, under frequency, voltage, current, unbalance, and load loss, jamming, jogging. These are the some different abnormal operating conditions. These also we can study. Okay, thank you.